A solid E bounded by the equation 9x squared plus 4y squared plus z squared equals 1 and located in the first octant is represented in the following figure. Part A says write the triple integral that gives the volume of E by integrating first with respect to z, then with respect to y, and then with respect to x. So the first thing we're going to deal with here is that z there. So we want to find our bounds for our z. So I think we'd be okay since we're in the first octant that we have this z equals 0, and that's really the xy plane, so that would be here. So that's the lowest our z could be, is 0. So I would say we have the 0, and then we have this equation right here that it goes up to. So it's going to go up to that equation there, and it's going to do that for the entire region xy there. So what we're going to do is we're going to solve this thing here, this equation, for z. So we know right away that our z was 0, and then we have z squared equals, and again I just moved everything over to the other side, so minus 4y squared minus 9x squared, and then I square root both sides. So I get z equals plus or minus the square root 1 minus 4 y squared minus 9x squared. Now think about it this way. This kind of runs into the same issue as the last problem. Since I'm in the first octant, I mean not even the first octant, if I was on the upper half of the xy plane, above the xy plane I should say, I would only have to consider the positive one. So I can take this negative away. But just realize that it's always there. It's just sometimes I don't need to use it because of the bounds of the integral, or the bounds of the region I have. Okay, so there's my bounds for my z. So here's my lower bound here, and here's the upper bound. All right, so now that we have our z, we have to get our x now. Is our x next? No, our y. We're going to do our y next. So we have to get our y set up now. So that tells me once z is completed, in a sense I just zero my z out. And the reason why I plug in my z equals 0 is because that's going to be the furthest that x and y could be. So x can go out the furthest here, and y could go out the furthest here. So that tells me then that if I plug in 0 for z, that's going to give me my parameters for my y and for my x. So really the equation, when my z equals 0, I get 9x squared plus 4y squared equals 1, because this becomes 0 here. And then for this one, now I have to solve for either x or y, but since I am doing a dy here, doing my integral with respect to y next, that tells me then that I would have to solve this for y. So I'm going to move the 9x squared over. So this is going to be 4y squared equals 1 minus 9x squared. And then I move the 4 over, so that's going to be y squared equals 1/4. Actually, I'm going to keep it together here because I see something kind of nice coming out of this. So 1 minus 9x squared over 4, and then I square root both sides. And this is going to be a y equals, and I get the plus or minus again. Anytime I square root, I get that plus or minus. So on the top, I'm going to get square root of 1 minus 9x squared, and it would be over 2 because the square root of 4 is 2. So I can actually square root it. So this is going to be what I end up with here. Now, do I need the minus? Do I need the plus? That's what we have to figure out now. So now if I plug in 0 for x, so if I plug in 0 for x, that's going to bring me down here. And that would tell me what my y value would have to be. Now I should get 0.5 for that, or somewhere in there it looks like. So let's see. So when I plug in a 0 there, that's going to be square root of 1. So it gives me the 1/2. So yeah, and then when I plug in... So again, I'm just dealing with this mapping. So like I said, if I plug in x equals 0, the y is going to equal 1/2. And that's what I see here. It goes from 0 to 1/2 for my y. And then when I plug in x equals 1/3, and I picked 1/3 because notice I have to square it here. And then when I square it, it's going to give me 1/9. So I really have the square root of 1 minus 9 times 1/9 over 2. And 9 minus 9 times 1/9, those cancel and I get a 1. So it's really 1 minus 1 here. And 1 minus 1 is 0 over 2, which is 0. So this would result in y equals 0. So that tells me then that my y equals 0 on this line here, and my x would be 1/3. So it would actually be this point here. So I just plotted this point here and this point here. So that tells me then that I don't need the negative here. All I need is the positive one, and that will give me all that I need. So then my y bounds are, and I didn't talk about the lower bound for y, but since I'm in the first octant, my lower bound is going to be y equals 0, and my upper bound is going to be this function here, a function of x. So now for the last one, we actually found those when we did the plugging in the x values. So we realized that my x could be from 0 to 1/3. And if I didn't know how to find that 1/3, if I wanted to be more precise about it, I just looked at it and kind of imagined what would work there. If you weren't sure, you could simply say that, hey, since we're in the first octant, my y has to be 0. So I can say 0 equals square root of 1 minus 9x squared over 2, and just solve this. So I'd multiply both sides by 2. And that would give me 0 equals square root of 1 minus 9x squared. And then I square both sides. And I'm going to move this up to the top here. I need some more room. And then I'm going to square both sides. So I'm still going to get 0 equals 1 minus 9x squared. And then I'm going to move the 9x squared over just because I want the x squared to be positive. Okay, and then from here, I'm going to move the 9 over. So that's x squared equals 1/9, because I'm going to divide by 9. And then I'm going to square root both sides. So that's going to be x equals plus or minus 1/3. But since we're in the first octant, we don't need the negative one. So x equals 1/3. And see, I found it just the same. So I could do it that way, just doing it simply algebraically. So now that we have our bounds for all of our change the respect to z, respect to x, and respect to y, since we have all our bounds for the x, y, and z now we can proceed and set up the integral as it requested. So without cutting everything out, the x was last. So the x was from 0 to 1/3. And the y was from 0 to 1 minus 9x squared over 2. And then the x was, or the z was from 0 to square root of 1 minus 4x squared, or y squared. Let me fix that y. Minus 9x squared. Oh boy, I ran out of room here. And that's going to be a 1 here. And then I'm going to go dz. Let me move this over. dy dx. And it's going to be a 1 because it says, write the triple integral that gives the volume of E. So remember, when we're talking about volumes here in a triple integral, that f of xyz is going to just equal 1, and that'll be enough to get us the volume that we need. Now the next directions for part B says, and that's our direction for part A. So part B says rewrite the integral as in A as an equivalent integral in 2 other orders. They said 5 originally, but there's no way we're going to do 5 in under 15 minutes. Hopefully I'll try to stay about there. But anyways, we got to do 2 more of these now. Now the other ones become a little easier, I think. The first one's the most difficult for us because it's a new process. So to do a different integration here, we got to pick 2 other methods or 2 other ways or orders to integrate. So now I'm going to pick the triple integral of dx, dy, dz. And again, this is going to be a 1 here, and this is my e, just because it's volume we're looking at here. So if I'm going to do dx first, I'm going to take this equation here and just solve it for x instead of z like we did in the beginning. And my lower bound is still going to be 0 because we're in the first octant. So to solve that for x, I'm going to just move the y over and the z over. So that's going to be y squared minus z squared. And then I'm going to move the 9 over and square root both sides. So this is going to be x equals plus or minus the square root of 1 minus 4y squared minus z squared. And that's going to be over 3 because I just did that part in my head there. So I wanted to keep the space limited in this. So we see that the x then is going to be just the positive one also. So it's just going to be this here. So I'm just going to move this over here because that's my upper and lower bound for my x now. Now I'm going to do the upper and lower bound for my y. So now that my x is gone because I dealt with x already, upper and lower bound, it's like this goes away in my equation. And I'm just dealing with oops, 4y squared plus z squared equals 1. And since I'm doing y next, I'm going to just solve this for y. So I'm going to move the z over and divide by 4 and square root both sides. So it's going to be y equals, and I'm not going to do the plus or minus anymore either because hopefully you see that I don't need it. But this is what I'm going to end up with. And my y, again, because I'm in the first octant, it's going to be y equals 0 to that function there. Y equals square root of 1 minus z squared over 2. And hopefully you're okay with that. And then for the third bound, which is going to be my z here, again, lower bound because it's in the first octant is z equals 0. And then for the upper bound for z, like I said before, I could put my y equaling 0. And then I would have the square root of 1 minus z squared over 2 and just solve for z. So I move the 2 over. I have the square root of 1 minus z squared equals 0. And then I square both sides. And then I have 1 minus z squared equals 0 again. I move the z over. I get z squared equals 1. I square root both sides. And again, I'm in the first octant, so z equals 1. So there's my upper bound and lower bound for z. So I have everything I need now to set up this triple integral. So this triple integral is going to be the lower bound is for my z is 0 to 1. And then for my y, it's going to be 0 to the square root of 1 minus z squared over 2. And then for my upper bound, it's my lower bound, upper bound for my x now, it's going to be 0 to the square root of, that would be here. So that would be 1 minus 4y squared minus z squared all over 3, and then I have a 1 here, dx, dy, dz. So that's my other way to set this one up, and we're going to do one more method. So then for the third one, let's do we'll do dy dx dz. So if you got the idea of all this now, you can stop the video here, but I'm going to go through one more just for the sake of going through one more. So we're going to do dy first. So I'm going to take this original equation here, and I'm going to solve it for y. So that means that's going to be 4y squared equals 1 minus 9x squared minus z squared. And then I'm going to move the 4 over and square root both sides. So that's going to be 1. And I'm only going to take the positive because I'm in the first octant. So 1 minus 9x squared minus z squared square rooted over 2. And my lower bound for the y is going to be y equals 0. And I'll write that to the left for the sake of room. All right, so there's those two bounds. So now I'm going to do the x bounds. So now with the y's out of the way, that's zeroed out. So I really have, for the x's, x equals 0 is the lower bound. And then I'm going to have the equation 9x squared plus z squared equals 1. And I'm going to solve this for x because I'm doing dx next. So I'm going to move the z over. So I got 9x squared equals 1 minus z squared. And then I'm going to move the 9 over and square root both sides. So I'm going to get x equals 1 minus z squared square rooted over 3. And the positive one because we're dealing with the first octant. Okay, so then for the last one, I can set my x equal to 0. So then my lower bound for my z, though, is z equals 0. And then I'm going to plug that in. So that's going to be 1 minus z squared over 3 square rooted equals 0. So I'm going to multiply both sides by 3 and square both sides. And that's going to result in 1 minus z squared equals 0. And then I'm going to move the z squared over and square root both sides. And I'm going to end up with z equals 1. Really plus or minus 1, but I need just the positives. So z is going to run from 0 to 1. So now I can just put my bounds in now. 0 to 1 was my z. My x was 0 to this guy right here, which is 1 minus z squared. And that would be over 3. And then for my y bound, and that's here, that's going to be 0 to, so there it is, the 1 minus 9 squared minus z squared over 2 is my upper bound. So that is how I can set this up in 3 different ways, in 3 different orders, I should say, of integration. So they told us to do 5. That would have took a really long time. So hopefully that helps. And again, sometimes it's better to set it up a certain way for the sake of the integral itself, not necessarily just the bounds.